All right, so in section 1.5, we're going to talk about quadratic equations. So first, we're just going to talk about the general form, which is ax squared plus bx plus c equals 0. So where we have everything over on one side equals 0, and then we're going to put it in descending order of exponents, so the x squared, then the x, and then the constant. There is a note here that the a cannot be 0. What that's saying is there has to be an x squared for it to be a quadratic equation. So we've actually already talked about quadratics. We've already graphed them and done transformations with parabolas. For this page, though, let's focus on being able to pick out the a, the b, and the c. So for our first problem here, the a is going to be this 2, the b is going to be this -3, and the c is going to be 5. For our second example, the a is going to be a -7, the b is going to be 8, and the c is going to be 0. This is the same thing as -7x squared plus 8x plus 0 equals 0. And then for c, so for our third example, the a is going to be the 3.59. The b, there's no x term, so that's going to be 0, and then c is going to be that 0.24. And again, this can be rewritten as 3.59x squared plus 0x plus 0.24 equals 0. And then for d, d is a little bit tricky because it's not in general form. We have to move this 8 over by subtracting 8 from both sides. So that's going to give us a -6x squared minus 9x minus 8 equals 0. And then whenever we're finding our a, b, and c, we're going to hit -6, -9, and -8. All right, we're going to talk about the zero product principle. And again, this is mostly review. So this is the idea that if we're multiplying things together and it equals 0, then at least one of those things we're multiplying is 0. So at least one of those factors is 0. So this is the idea of us going through and factoring and then setting each factor equal to 0. So here, for our 5x squared minus 20x is 0, we can factor a 5x out. So whenever you're factoring, you're always going to look at all the terms and see if there's anything in common amongst all of them. So there's a 5x in common, and that's going to leave us with x minus 4, and that'll equal 0. And if you want to double check, just 5x times x is 5x squared, and 5x times a -4 is a -20x. So once we get to here, we're going to take each term and set it equal to 0. So I can take 5x and say that that equals 0, or I could have just done the x. Because technically this is 5 times x minus 4, where 5 would be a factor, x would, and then the x minus 4 would be. But if there's not a variable, then you would not set it equal to 0. For instance, if we only pulled out a 5, we would not say 5 equals 0. So whenever we solve for x here, we're going to get x is 0, because 0 over 5. And again, that's why we could have just said x equals 0 right away. And then for the x minus 4 equal to 0, we're going to add 4 to both sides and get that x is 4. So our answers are going to be both the x is 0 and x is 4. And to double check, we just would have plugged our answers back in. Hopefully you can see pretty quickly that plugging in that 0 works. So 5 times 0 squared minus 20 times 0 is 0. So 0 minus 0 is 0. And then for plugging in the 4, 4 squared is 16. 16 times 5 is 80, minus, and then 20 times 4 is 80. So 80 minus 80 will give us 0. For b, we're going to have to go through and move everything to one side first, since we're factoring to solve. So we're going to add 9x to both sides, and we're going to subtract 10 from both sides. So we end up with x squared plus 9x minus 10 is 0. Because there's just a 1 in front of the x squared, we know it's going to be x and x. We need to multiply to a negative 10, but add to a positive 9. So we know that 10 and 1 will work. We're going to have opposite signs to multiply to a negative. Because we're adding to a positive 9, the larger number has to be positive. So it's going to be plus 10 minus 1. And then we're going to take each of these and set equal to 0. And here we're going to subtract 10 from both sides to get that x is negative 10. And here we're going to add 1 to both sides to get that x is 1. Okay, now we're going to talk about the square root property. So the idea of the square root property is that if we can get whatever it is squared equals the other parts, then we can just take the square root for a really good first step. So usually whenever people see x squared equals 49, people will right away go, oh, x is 7. Well, that's true. But x could also be negative 7. So the trick here is that whenever you're taking the square root of both sides, you have to do plus or minus over here. So you're going to get that x equals plus or minus the square root of 49. Well, that's going to be that x is plus or minus 7, and then to list that out, that means that x is going to be 7 and negative 7. So for b, it's not quite the same, so 3 times the x plus 4 squared equals 21. Again, whatever it is that's squared, we have to get by itself on one side. Do realize that whatever it is that's squared is going to contain the variable, and that should be the only place that the variable exists. So our first step here to get this x plus 4 squared by itself is going to be to divide both sides by 3. So we're going to get x plus 4 squared equals 7. So 21 divided by 3 will give us 7. And then we're going to do square root. And again, we have to do plus or minus over here. So we're going to end up with x plus 4 equals plus or minus the square root of 7. We're going to move that 4 over. So we're going to subtract 4 from both sides. And we're going to get x equals negative 4 plus or minus the square root of 7, which we'll need to write out to be x equals a negative 4 plus square root of 7 and a negative 4 minus the square root of 7. So for our third example, we're going to have a couple extra steps before we can get the thing that's squared by itself. So the first thing we want to do is, again, we're trying to get this x minus 3 squared by itself. So we're going to move this negative 7 over. So plus 7 on both sides. So we're going to have 2 times x minus 3 squared equals negative 8. And then we need to divide both sides by 2 to get this 2 to go away. So we're going to divide both sides by 2. And we're going to get x minus 3 squared equals negative 4. Well, now that we have the thing that's squared by itself on one side, so that x minus 3 squared, we're going to take the square root of both sides. And this will be plus or minus. So we're getting x minus 3 equals plus or minus the square root of negative 4. Remember, anytime you're taking the square root of a negative, it's going to come out as an I. So the square root of negative 4 is going to be 2i. And now we're going to move this 3 over. So plus 3 on both sides. And we're going to get x equals 3 plus or minus 2i. So that means that x will be 3 plus 2i and 3 minus 2i. And lastly, let's talk about the quadratic formula. So on the first page, we had to identify A, B, and C. Well, one of the great reasons for doing that is to use the quadratic formula. You will need to memorize this. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So one of the biggest mistakes I see is people don't divide the entire thing by 2a. So we want to go through and use the quadratic formula for A for our first example. A is 2, B is a -4, C is a -1. So if we're doing opposite of B, we're going to have -4 plus or minus the square root of -4 squared, so B squared, minus 4 times A, which is 2, times C, which is -1, all over 2A, and then A is 2. So here, -4 is going to give us 4, plus or minus the square root, so -4 squared will give us 16, and then minus 4 times 2 times -1 is going to be plus 8, all over 4. So this will be 4 plus or minus the square root of 24 over 4. And the square root of 24 is equivalent to 2 root 6. So we have 4 plus or minus 2 root 6 all over 4. Now I want to point out that we can do some reducing, but the reducing here can get a little bit confusing. So people will often try to just cancel these 4's. Well, you can't do that because of the plus or the addition and subtraction right here, so the plus or minus. That means that this 4 plus or minus 2 root 6 is considered one term. However, we can factor these 2's out. So that'll be left with 2 times 2 plus or minus the square root of 6 all over 4. And so if we wanted to double check, 2 times 2 gives us 4, and then 2 times root 6 is going to give us 2 root 6, where we've kept the plus and minus. And then we have a 2 and a 4, and now we can reduce because of the multiplication on top. So this 2 is going to go away, this 4 is going to become a 2. And so we're ending up with 2 plus or minus the square root of 6 all over 2. And then this is done. Again, you cannot cancel these 2's. And if you want to get the answer for my math lab, we'll just need to separate that to 2 answers. So 2 plus the square root of 6 over 2, and 2 minus the square root of 6 over 2. And I do want to remind you that your Casios are great at this. So if we wanted to plug in this original problem here, we would start by using one big fraction, and we would have a -4, and then we can't do plus or minus at the same time, so I'm just going to pick plus, and then the square root of -4, don't forget your parentheses, squared, minus 4 times A, which is 2, times C, which is -1, and then all of that is going to be over 2A, or 2 times 2. If you hit equal, here it's going to give you that 2 plus the square root of 6 over 2. Now, if you want to go back in there and just correct that plus to a minus, this is going to give us our second answer. So the 2 minus root 6 over 2. So again, your Casio is also a useful tool.